Okay, in this video we're going to be looking at radians. Basically, radians is another measure of turn. So traditionally, or up until this point, we've used degrees as our measure of turn, where 360 degrees is a full turn, a full revolution. We're now going to look at the radians. So what one radian is, a radian is the angle subtended at the center of a circle by an arc equal to the radius. So if you look at this example here, the radius is r, and the arc is also has a length r. So the angle at the center would be equal to theta. Okay, and so it wouldn't matter if the arc had been 100 centimeters long as the radius was also 100 centimeters long, this angle would be 1 radian. Okay, from this we can get to here, which is very important. So there's a wee bit of working out here, but the bit that really is important for us is this, that pi radians is equivalent to 180 degrees. And just how another way we could write that, the symbol for radians, degrees, it's a wee circle, but for radians, it's a wee small c up in the air. So pi radians is equivalent to 180 degrees. And we can use that to convert from radians to degrees and vice versa. So you really must learn that. So if you had 1 radian, then if pi radians was equal to 180 degrees, 1 radian is going to be 180 divided by pi, which is approximately equal to 57.3 degrees. Likewise, 1 degree is pi divided by 180 radians. So you can use this reconversion to go from radians into degrees, and also this reconversion to go from degrees into radians. So we're going to do that and then show in these examples here, and then show another way that we could do this as well. So a quicker way maybe as well here. Okay, so for this one, we've got pi over 2. So pi over 2 radians is pi over 2 times 180 over pi. And if you do that, the pi's will just cancel out, leaving you 90 degrees. Or a nicer way of doing it really would be just to say we know pi is equivalent to 180 degrees, and 180 divided by 2 is just 90 degrees. Okay, so the second, this one, we're going to do it the awkward way and then the better way. So we just convert by multiplying by 180 over pi, and then that would be equal to 360 degrees. Or we know that pi itself is 180 degrees, so 2 pi is 2 times 180, so 360 degrees. Okay, the last of these type, and I wouldn't be doing it, definitely wouldn't be trying to think about this one as the easy way. I'd just be thinking, right, I've got my 7 pi over 15, and then I'd multiply by 180 over pi, and if you do that, you'll get 84 degrees. Okay, what you may want to do is just think 180, pi is 180, on your calculator and do 180 divided by 15, and then multiply by 7. That would give you it as well, but it's the same thing really as this method. Okay, next one, it says convert into radians. So we've got 30 degrees. So 30 degrees is the same as 30. And then to get into radians, we're going to multiply by pi over 180. And then that's going to be equal to pi over 6, and then the wee symbol for radians. Or if you think about it, 30 degrees is 1/6 of 180. So it's just pi over 6. Okay, 150, same idea. We can say that's 150 times pi over 180. And if you do that on your calculator, you'll have 5 pi over 6 radians. Okay, and this one, 48, so it's just 48 times pi over 180. Again, bang that into your calculator and you will get 4 pi over 15 radians. Okay, we're not going to go through at this stage where these come from, these formulas, but we have a couple of very important formulas. As the area of a sector is a half times r squared theta. Well, that's where theta is in radians. So the sector is like the whole pizza slice here, and the area of the sector is half times r squared times theta, and that's where theta is in radians. The arc length, so the arc length is this length here, and it is going to be theta over 360 times 2 pi r. That's if you're doing it in degrees, but we can get down to here. This is the one we're looking for really. So your arc length, S I've called it, is equal to r theta. So two very, very important results for us there. We're going to look at a couple of examples on these now. Okay, first example says the area of a sector OAB is 150 centimeters squared. The radius has a radius of 12, and calculate theta, and then find the length of the arc AB. Okay, I'm going to do a diagram just to keep me right here. We have got that as there's my sector, that's 15, sorry, that's theta, that's 12 centimeters is my radius, and that is 150 centimeters squared, and I'm going to use, what have they called it? They called it S for the arc length, so we'll use the same thing here. So we'll say that's what we are trying to find eventually, but what we know is your area of your sector is 150 centimeters squared. So that means 150 is equal to a half r squared theta, and we know our r is going to be equal to 12, so that's going to be half times 12 squared times theta. So that's 150. 12 squared is 144. Divided by 2 is going to be 72 times theta. And then we'll go over here and we'll just do the 150 divided by the 72 to give you your theta. And if you work it out, you will get it is going to be equal to 2 and 1/12, and that is going to be radians. Once you've got your angle at your center in radians, then you're good to go to find your arc length. So the formula they had given us was r is equal to is equal to r theta. So in this case, the radius was 12 times 2 and 1/12. And you can nearly do that in your head. 12 times 2 is going to give you 24. 12 times a 12 is going to give you 1. 24 plus 1 is going to give you 25 centimeters. In this example, it says a circle has a center O, an arc PQ has a length of 12.5 centimeters, and the angle POQ is 2.84 radians. Calculate the radius of a circle to two significant figures. Okay, I'm going to do a diagram again for this. So not the best diagrams in the world, they don't have to be. That is 2.84 radians at the center. We don't know r, but we do know the arc length is 12.5 centimeters. So arc length S was equal to r theta. So we're going to say 12.5 is equal to r times 2.84. And then a wee bit of working out, the 12.5 divided by the 2.84 is equal to your r. And that's worked out for me as my r being 4.4 centimeters. Okay, let's read the question. Calculate the radius of a circle to 2 sig figs. We've done it. So that was us just put in our 2 sig figs to show we have it done. Example 3 says a sector of angle theta in a circle of radius r centimeters has a radius of 5 centimeters squared and a perimeter of 9 centimeters. Find the values of r and theta. Okay, we diagram again. You've got your radius here, and that's my arc length S, and that's my theta, and the only thing we know is that is 5 centimeters squared for this area. We also know the total perimeter is equal to 9. So we're just going to go. We'll start with that one. We'll say my S, total perimeter of the S plus 2R is going to be equal to 9. So that's going to be R, or my arc length is R theta, remember. So R theta plus 2R is equal to 9. And I'm going to call that equation 1. You can probably guess where we're going with this one. We also know your area is equal to a half R squared theta. And we knew the area of the sector was 5. So 5 is equal to a half R squared theta. It's a wee bit awkward to work with, so I'm just going to multiply both sides by 2 to give me 10 is equal to r squared theta, and I'll call that equation 2. So we've got equation 1 and equation 2, and so we've got 2 equations with 2 unknowns, so we should be able to solve this from here. So what we're going to do is I'm going to just rearrange my equation 1. So I'm just going to say rearrange equation 1, and if I do that, I've left out a wee bit of working out, but just making your equation 1, making theta the subject, I will get 9 minus 2r all divided by r for my theta. And then what I want to do is just say sub into equation 2. So we're going to put my new arrangement for theta into equation 2. So equation 2 will now become 10 is equal to r squared times my theta, which is 9 minus 2r over r. Okay, this looks very difficult, but it's not difficult at all. You've got r squared here, which is multiplying this thing. So what one of these r's will do is cancel out this one. You're going to be left with an r. So the next line is very easy. It's just going to be 10 is equal to, and as I say, one of the r's and the r squared gets cancelled, the one on the bottom. So you've just left with r upon 9 minus 2r. And then we just multiply that out and tidy up. You're going to have 10 is equal to 9r minus 2r squared. Bring everything to one side, put it equal to 0. 2r squared minus 9r plus 10 is equal to 0. And then we want to just do our sum and product method to solve this. So we'll just go up here and I'll write that out again, running out of space. So I've got 2r squared minus 9r plus 10 is equal to 0. My sum is equal to minus 9. My product is equal to 20. So my two numbers, let's just go through. We've got minus 1 times minus 10 minus 2, minus 1 times minus 20 minus 2 times minus 10. We've got minus 4 times minus 5, and there we go, we found it. So we have 2r squared minus 4r minus 5r plus 10 is equal to 0. Take 2r outside the bracket, leaving you r minus 2, and take minus 5 outside the bracket, leaving you r minus 2. You know you're on the right track because you've got the common bracket. So just write down your common bracket, which is r minus 2, and then write down the other one, which is 2r minus 5. So that means r minus 2 equals 0, which means r must be equal to 2, or 2r minus 5 equals 0. Do a wee bit more working out that one, which means 2r equals 5, which means r is equal to 2.5. Okay, read the question. Have we done it? It says find the values of r and theta. So we've done the r bit, we have to find the values of theta. So we just say when, a wee word every now and again is a big help. So when r is equal to 2, theta is equal to, and we're going back to this formula over here. So we're going to put r equal to 2 into this formula over here and see what we get. So that's going to be, top line is going to be 9 minus 2 times the r, which is going to be 4, all divided by 2. So 9 minus 4 is going to be 5, divided by 2 is going to be 2.5. And this one we will say when r is equal to 2.5, theta again is going to be 9 minus 2 times the r, which is going to be 5 this time, divided by 2. So theta is going to be 9 minus 5 is going to be 4, divided by 2 is going to be, it's divided by 2.5. So it's 9 minus 5, then divided by 2.5, which is going to be 1.6. So your answer for this one, you've got r is equal to 2, and then it had a corresponding value of theta, which was 2.5. Or you could have r is equal to 2.5, and the corresponding value of theta was 1.6. Okay, we're going to look at segments. Now a segment is just, if we look at this diagram, just a segment is a wee section of a circle which is cut off by a chord. So a chord is just a line which is from 2 points, connects 2 points on the circumference of a circle. So here you can imagine this sort of peach colored here, this wee bit is called the minor segment, and everything on the other side is called the major segment. Okay, the area of this triangle, to find the area of this segment, it is clearly the area of the whole pizza slice or the whole sector minus the area of this triangle. So the area of that triangle, the area of this triangle comes from the formula half AB sine C. So that's where you have two sides of a triangle and you have their enclosed angles, the angle between them, which is C. So in this case, A and B, the two sides of the triangle, are both the same, they're both r, and the angle between them is theta. So it's a half times r times sine theta. So a half times r squared times sine theta. So that's where that comes from. That is worth your while to learn that the area of these particular triangles is a half r squared sine theta. Okay, so the whole shaded area is a half r squared theta. That was the whole area of the sector minus the area of the triangle. Okay, I'm just going to write that in words here, and then I'm going to add that into the formula. This is absolutely fine, but I just prefer having it in the long way as well. Okay, so we've just written that in. It's area of the segment, so that's the tiny wee bit that's cut off is just equal to the area of the whole sector or the whole pizza slice minus the area of the triangle. So again, we'll just write that in properly and write that in your own handwriting here, this wee bit as well. So your area is equal to area of the sector, remember the pizza slice is a half r squared theta minus area of the triangle is a half r squared sine theta. And you can see how that just abbreviates this. What we've done is we factorized out a half r squared, leaving you theta minus sine theta. This example says O is the center of a circle of radius 6 centimeters. AOB is a sector of angle pi over 3, and find the area of the sector AOB. So first thing I'm going to do is just, as always, do a diagram. So A, a very basic diagram. I've got my sector, my pizza slice, and the angle was pi over 3 radians. The radius was 6 centimeters, and we're good to go. So my area in this case is just going to be equal to a half r squared theta, and that's just going to be a half times 6 squared times pi over 3, and file that into your calculator and it gives you 6 pi, and that's going to be centimeters squared. So that's an exact perfect answer. More likely an exam I would just leave it as that. If you want, you can give it the 3 sig figs or whatever it says in the front of the exam paper, just to be absolutely sure of getting your marks, but that will be fine. And part B, it says find the length of the arc AB. So we don't need to draw a new diagram. So our arc, the formula they're using is S is equal to R theta. So in this case, it's going to be 6 times pi over 3. And if you do that in your calculator again, that's just going to give you a nice 2 pi, and the units are going to be centimeters. Okay, part C says find the area created if find the area of the created segment if a chord is drawn from A to B. I'm just going to do a wee diagram again for this one, just so I don't mess up my original diagram. Right, use your imagination here. That is a wee sector that we're looking for. That's my A, that's my B, and that's the O. That was 6 centimeters as before. That was pi over 3 centimeters. And I'm just going to write down my long formula. So area of the segment equals the area of the sector minus the area of the triangle. Squeezing that in just about. Okay, so the area of the sector. And if you've done some of the working out already in an earlier part, by all means use it. So we already know the area of the sector. We've already worked this out over here. It was 6 pi. So let's not be wasting any time here. That is just 6 pi. Dead easy. That's done for us. The area of the triangle, we'll write out the formula for it was a half r squared sine theta. Now, when you're doing this, folks, make sure you've got your calculator in radians mode, because you're now working with angles, trig angles, so sine, and this angle needs to be in, this angle is in radians, so your calculator needs to be in radians mode too. So just put in what we know, that's 6 pi minus half times my r, which is 6 squared, times my sine of my angle, and my angle in radians is pi over 3. Hit that all into your calculator, and well, I've actually just hit the second bit into my calculator to give me an exact answer for it, just to have a look and see what it looks like. So it's 6 pi minus 9 root 3. Probably wouldn't leave it the gap for my answer, so write that to 3 sig figs as 3.26 centimeters squared, and that's the 3 sig figs.